Welcome back to the walkthrough series, and this is the second part to the 961841 November 2024 paper, and we're looking at the second question, which is number 2. Alright, so it says here that a computer program is designed to simulate horses doing show jumping. In show jumping, horses jump over obstacles called fences. Then a horse successfully jumps a fence if it does not knock the fence down. Then we all have the class diagram given here, right? And we are told that the program is going to be using OOP as the programming paradigm. Then we are given this class diagram for the horse, and part A, item 1, requires us to write program code to declare the class horse and its constructor. Then do not declare any other methods. Use your programming language's appropriate constructor. All attributes must be private. If you are writing in Python, include attribute declarations using comments. Then our main program is going to be saved as question 2. This is the main program. So you see here on my in my code editor that I already have question 2. This is my main program. Then of course I'm using the Java convention, right? In Java, the Java convention is we don't use underscores in class names, so that's why I don't have an underscore in there. But maybe let's just turn to the solution. For 4 marks, we are supposed to create the class called horse. So this is the horse class, rather the class definition for horse. And we have 1, 2, 3 attributes, right? So remember that attributes should be labeled private, or should be marked private. So we have the attribute name, max fence height, and percentage success, right? And they're all marked as private. Then we also need to declare the constructor. So you remember in Java, the constructor shares the same name with the class. So here our constructor on line 7, rather line 8 through 12, that's where we have our constructor. Then for that, you copy your code and you paste it in the evidence document, and you get your 4 marks. Then moving on to item 2, we are supposed to write code for the get methods, get name and get max fence height, then return that particular attribute. So our getters, we have them from lines 14, rather lines 15 all the way to 21. So we have the gate name and the gate max fence, and in each instance we are returning the appropriate attribute. And for that we get 3 marks. Then moving on to B, so the array horses stores objects of type horse. The program has 2 horses. We are going to have a horse called Beauty that can jump a maximum height of 150, then has a percentage success of 72. Then the second horse is called Jet, and it jumps a maximum height of 160, and it has a percentage success rate of 65. So we have to write a program code that's going to declare the array horses, local to the main program. So this means that we are now switching to the question 2 N24 file, and that's where we are going to declare our array of size 2. So we do that on line 8 right there. Then we are going to store the 2 horses with the given attributes, right? That is the name, as well as the maximum height and the percentage success. So in the first position, in the first index position, we are going to have the name of the horse as Beauty, then the maximum height is 150, and the percentage success is 72. So you realize that in this particular instance we are now creating a horse object, right? And we are now also calling the horse constructor, and passing those arguments right there. So we do for the other horse, and we store it in index position 1. Then after that, we're supposed to output the name of both horses objects from the array. So we now make use of the get name of the getter called get name, So out.println, then host 1 we output the name, then host 2 we output the name. Then item number 2, we are to test our program and take a screenshot of the output. So what I can do here is I can comment out this part right here so that we only see what we are required to show, as it were. So let me just quickly comment out everything down here. There we go. All right. So test the program, and let's go ahead and run the main method right here. And you see that host 1 is beauty and host 2 is chat. Then you are going, this is where you would take your screenshot and you would paste it inside of the evidence document for 1 mark. So now let's move on to part C. So the class fence stores data about the fences. Each fence has a height in centimeters and a risk number. The risk is a whole number between 1 and 5 inclusive. A risk of 1 means the fence is the easiest type to jump. A risk of 5 means the fence is the hardest type to jump. So this is the class definition for fence, and we have to write program code to declare the class fence. So let's switch to this fence file. So we have 2 attributes, and they are both of type integer. So we have private int height, private int risk. Then we also need the constructor for the fence. So line 7 through 10, we have the constructor going on there. Then we are supposed to also, we have the getters for height and risk. So get height and get risk. Then you copy your code and you paste it in the evidence document. Then item number 2, the array course stores 4 fence objects. The user inputs the height and risk for each fence, and these are validated before each fence is created. Amend the main program to declare the local variable course. So we want to do these other 3 things besides just declaring the local array. So we'll come to the main file. This is our main file, by the way, question 2n24. So let me uncomment the code, the solution to this. So it says here that we have an array called course. So right there on line 17, we are declaring the array called course, which is going to store fence objects. So you can see that the data type is fence, and the name of the array is course, and the size of the array is going to be 4, because we are told that we are going to have 4 fence objects. Then we are supposed to declare the local array course. That's what we did on line 17. Take as input the data for 4 fences from the user. Loop the input until both the height and the risk are valid for each fence. Create an instance of fence for each of the 4 valid fences and store each instance in an array. So we are making use of a loop to take in the 4 pieces of data that we need for each fence. So here we want to store the height and the risk. So the first loop right here is going to take the height of the fence. Then the second loop is going to, the second nested loop rather, is going to be taking the risk for each fence. So you notice that we are using, we are going to iterate, we are nesting loops, is it? So the outer loop is going to run 4 times. Then the inner loops, they are going to validate a height that is between 70 to 180. So we have 2 of them, right? Notice they are not nested, but we have one coming after the other, so that once we have taken a valid height, move on to take in a valid fence. Then we are going to store each of these inside of the array that we just declared in line 17. Then you would go ahead and copy this code and paste it in the evidence document. Then we move on to the next part, which is D. So the chance of a horse jumping a fence without knocking it down is calculated as follows. If the height of the fence is more than the maximum height a horse can jump, the success percentage is 20% of the horse's percentage success. the risk does not affect this value. If the height of this fence is less than or equal to the maximum height a horse can jump, the risk gives a modifier value to multiply with the horse's percentage success. Then the risk values and the modifiers are given in this table. For instance, if a horse has a percentage success of 65, the maximum height and the maximum height of 160, a fence has a height of 140 and a risk of 3. The height of the fence is less than the horse's maximum height, therefore the risk is used. The risk of 3 gives the modifier 0.8. The modifier of 0.8 is multiplied by the horse's percentage success of 65, giving 52. Then the chance of a horse successfully jumping this fence is 52%. So basically they're just explaining how these modifiers are used with percentage success and the maximum height, right? So our method success is going to be inside of the horse class, and it's going to take the height and risk of a fence's parameters, because remember we are going to use them to come up with a new value essentially. Then calculate the percentage chance of success for that horse jumping the fence without knocking it down. Then it's going to return the calculated percentage chance of success as a real number. Then we are to write code for the method success. So if you remember, it says here that it's supposed to be inside of the horse class. So you'd switch over to the horse class, and you actually see our implementation here of the success method. So it says that it takes two parameters, the height and the risk. So you have the fence height and the fence risk as parameters to the success method. Then if the fence height is greater than the maximum height, then it means that we are going to return percentage success multiplied by 0.2, because that is what they said right here when they said if the height of the fence is more than the maximum height a horse can jump, the success percentage is 20% of the horse's percentage success. So that's what we did on line 25 through line 26. That's where we have the logic 25 and 26. Otherwise we're going to have to calculate the to calculate the modifier, or set the modifier before you calculate return the percentage. So what we did in this case was to in the case of fence risk being 5, right, we are now using this information in this table right here. So we have a switch case going on, and we are testing for the cases 5 through 1, is it? So 5, 4, 3, 2, 1, you can actually see that the modifiers are matching. In the case that it's 5, the modifier is 0.6. In the case that it is 4, the modifier is 0.7, and so forth and so on. Then the last one is we are having a default value. In the case that it is 1, then the default value is going to be 1. After which we are going to take the modifier that would have been chosen in that particular instance and multiply it by the percentage success rate, and then return that as a real number. So it's going to be returned as a double in our case, because the return type we specified it as double right here on line 24. Then write program code for success. Then you'll go ahead and copy this code and paste it inside of the evidence document. Moving on to part E, item 1, write program code to amend the main program to calculate the output. Rather, calculate and output the chance of the first horse jumping each of the 4 fences without knocking each down. Calculate and output the chance of the second horse jumping each of the 4 fences without knocking each down. So let's go back to the main program. So what you see is that we need to calculate the chances for the first horse. We want to calculate the chance of jumping each of the 4 fences, is it? Then we also want to do the same thing for the second horse. So in this case we need to make use of nested loops. So let me just uncomment the code here and explain the logic behind using nested loops. So you're saying that the outer loop is for the horses. So you have 2 horses, right? So you see that we're initializing an index of 0 and it's less than 2. So this means that the outer loop is going to run 2 times. So 2 times is for the 2 horses that we have, that is Beauty and Jet. for instance. Then the inner loop is now going to iterate for each fence, it's going to iterate for each fence. Then for each horse we are going to calculate the success. So we are calling the success method on each horse, and in each particular instance we are now taking the course specified, that is the course is the fence that we are calculating. So we are calculating the fence's height and the fence's risk. Then after which we are going to output the horse Fox at fence 1 has a 68% chance of success. So that's what we are doing right here. But we are not printing print lining, right? We are print formatting our output. So here we are using a special kind of printing whereby instead of having to concatenate your numbers with your strings, you can essentially use these format specifiers. So %s is for string and %f is for floating point numbers or for real numbers. So that's what we are doing right here on lines 42 through rather it's 42 to 43. Then save the program and run the save the program and copy the code and paste it in the evidence document. Then item 2, write program code to amend the main program to calculate and output the average chance of success for each horse jumping over all 4 fences without knocking each down. So the average is the total of values divided by the quantity of values. An example output for one horse jumping all of the fences is the horse Fox has this average 70% chance rather of jumping over all 4 fences. Output the name of the horse that is the highest average chance of success. You can assume that each value, each average will be different rather. Then let's go ahead and look at that piece of logic that we have going on here. Alright, so we start by creating an array that is going to store the 2 averages for the averages. That's going to hold 2 average values. Then we are using a loop to essentially iterate through the average chances of jumping each fence, each of the 4 fences, that is for the 2 horses. So here we are calculating the success for each horse. Then after which we are going to divide the chances by 4 because we have 4 fences. Then again we are just using the format specified printing, right? So %s is for string, that's where the horse's name is going to be, and %f, that's where the chance is going to be. Then we would copy this and paste it inside of the evidence document. Then the final part, item 3, we are supposed to use that test data. So let's actually go ahead and use the test data. So test your program with the following input data for 4 fences. So we are going to use this. Then let's go ahead and run our code. Where's the main method? Right here. So we have 152 with a risk of 5. Then we have 121 with a risk of 1. Then we have 130 with a risk of 3. Then we have 145 with a risk of 4. So you see that we have the percentage chances for beauty, that is for each of the 4 fences, and it's also the same for jet, right? Each of the 4 fences, that is this the chances of success. Then we also have the average for the average calculated percentage, that is for all 4 fences, for beauty and for jet. Then the last part, it required us to find the horse with the highest average, and that piece of logic we have it going on here, right? So we are using a ternary operator in this case. Essentially what we are saying that is if in the average, if the average at index position 0 is greater than the average at index position 1, then we are going to set the best index to 1, otherwise to 0, sorry. Otherwise we're going to set it to 1. So that's how the ternary operator works. So essentially saying that if this, then that, else this is it. So we are checking to see if this condition is true, we want to set this one as the condition, otherwise we set this as the condition. So in this particular instance, jet has a greater average than beauty, so it means that we are setting the index to 1. So that is why you see it's going to print the horse with the highest average chance of success is jet right here, because we've set the best index to 1. So it means it's going to look inside of the array and take the horse that is at the second index position. So that's why we have the horse with the highest average chance of success is jet right there. So yeah, I think that's just about it for this walkthrough for the question 2. I'll see you in the next walkthrough for question 3.